Hello, welcome to Renew CCL. I am Noemi Martinez, and this is the first video called Intro to Sound. So we're going to talk about what is sound. In the air, acoustic energy travels and dissipates, creating changes in the air pressure called sound waves. So here I have my guitar as an example. And this is the source, right? So as I strum it, immediately the sound waves travel in the air and it vibrates and it goes into my ear. We have a sound wave, and then we have compression and rarefaction. So in the air, the molecules are compressed and then it lets go and dissipates. A cycle is one complete excursion of a sound wave. And it starts at the point of 0, and then it's gonna go all the way to 360. So it's very equal to a circle. So that is a cycle. So frequency is the number of cycles occurring in 1 second, and is also measured in cycles per second. 1 hertz is equal to 1 cycle per second. Or if I say 100 cycles per second is equal to 100 hertz. Sound travels through the air at a constant speed of 1130 feet per second, or 344 meters per second. And on a temperature that's standard, usually 59 degrees. So it is constant no matter what the frequency or softness or loudness. It also varies slightly according to the temperature, humidity, and atmosphere pressure. So that is the speed of sound, how fast it's going to travel that sound wave. Wavelength is the distance that a single cycle travels. So wavelength is measured in feet or meters, any unit of distance. The distance of that frequency in particular. So 1,000 cycles per second, or as we call 1K hertz, is only 1.13 feet away. That's how far it is. So that frequency will travel that distance because it's a low frequency. Remember, low frequencies travel farther and high frequencies travel at a shorter distance. Phase. Phase affects how much sounds add together. It needs to be controlled. It's measured in degrees. It's the time relationship of a sound wave or an audio signal to a known time reference is called the phase of the signal. So we have to know the time relationship of one wave to the other wave. We have a snare, for example. We want to be able to, if we want to put 2 microphones on that snare, we're going to have phase issues if we have 2 microphones. So because they might not be exactly at the same measurement or at the same level or at the same angle, and that causes phase. You could put a button called phase in or phase out on your console, will help take out or end the phase issues. And that is phase. So it's just making sure that you have the correct time relationship of a sound wave. An octave is a 2 out of 1 relationship of a frequency. The difference between similar notes. So for example, we have a 220 hertz or 220 cycles per second. The next octave would be 2 out of 1 relationship. So we're going to multiply it by 2 and it's going to be 440 hertz. And then we would go on and on to the next octave. So harmonics, its frequency is a whole number multiple of a fundamental frequency. What is a fundamental frequency? It is the first note of an instrument. For example, you could have the bass, maybe it could start at 40 hertz, so that would be the harmonic of that instrument. Human hearing frequency range. So our human ears are capable of capturing 20 hertz, which is 20 cycles per second, all the way to 20,000 cycles per second. That's not for everyone, because everybody during the time, our ears start, depending on our volume, what we use, the headphones, concerts, going different places, we start losing our hearing because of the levels. So we have to be careful. But we could hear, human hearing could capture from 20 to 20,000 hertz or cycles per second. So this is just the first part of Intro to Sound. We're going to continue to the second part, and if you like it, please subscribe.